Bismillahirrahmanirrahim. Dear students, today we are going to learn about Solvay's process, a topic of grade 10 chemistry, manufacturing sodium carbonate. A revolutionary industrial process that transforms simple raw materials into essential sodium carbonate through ingenious chemistry and engineering. Now, dear students, what is the fundamental principle behind? Number 1, low solubility key. Sodium bicarbonate has low solubility at 15 degrees Celsius, allowing selective precipitation from solution. Ammoniacal brine. Carbon dioxide passed through ammoniacal sodium chloride solution precipitates only sodium bicarbonate. Let's learn why Solvay's process is so successful. The reason behind is that raw materials are abundant and affordable. Our first raw material is sodium chloride, common salt or brine, readily available and inexpensive basic material. Limestone calcium carbonate, natural calcium carbonate source for generating carbon dioxide gas. Ammonia gas, essential catalyst that enables the precipitation reaction to occur. Dear students, there are a total of 6 steps in Solvay's process. Step 1 includes preparing ammoniacal brine. In this step, which is the foundation step, ammonia gas is dissolved into sodium chloride solution, brine, to create the reactive medium needed for the process. This ammoniacal brine becomes the starting point for all subsequent reactions in the carbonating tower. Dear students, then comes step 2, carbonation tower reactions. In this step, carbon dioxide is passed through ammoniacal brine in the carbonating tower. Ammonia reacts with water and carbon dioxide from the ammoniacal brine to produce ammonium bicarbonate, which is in dissolved form in the solution. That ammonium bicarbonate further reacts with sodium chloride to produce two salts, sodium bicarbonate and ammonium chloride. Here comes a very important step. Now we lower the temperature of these two salt solution that results in the precipitation of sodium bicarbonate. Temperature is lowered to 15 degrees Celsius to maximize sodium bicarbonate precipitation. Step 3 to 4, filtration and calcination. Dear students, as you already know that we have precipitated out sodium bicarbonate. Milky solution of sodium bicarbonate is filtered out. Then comes the calcination. Sodium bicarbonate is further heated to produce sodium carbonate. Sodium bicarbonate produces sodium carbonate, carbon dioxide and water. Sodium carbonate, that is the material that we want to prepare. Dear students, step number 5 is carbon dioxide generation and lime production. Limestone decomposition. Calcium carbonate is heated to produce calcium oxide, that is lime, and carbon dioxide. This process is done in lime kiln producing carbon dioxide for carbonating tower. Slake lime formation. Calcium oxide is then treated with water to produce calcium hydroxide. Quick lime slaked with water then pumped to ammonia recovery tower. Dear students, then comes step 6, ammonia recovery system. Ammonia is recovered from ammonium chloride solution using calcium hydroxide. Ammonium chloride reacts with calcium hydroxide to produce 3 compounds, ammonia, calcium chloride and water. This ammonia is one of the raw materials used during Solvay's process. All ammonia recovered and reused in the process with minimal losses. Fresh compensation. Minor ammonia losses compensated with fresh ammonia addition. Dear students, here comes the flow sheet diagram of Solvay's process. After going through this flow sheet diagram, you will be able to learn and understand the process easily. As you have already learned that our first step is the passing of brine to ammoniating tower, where ammonia gas is passed through the aqueous solution of sodium chloride. The result is the formation of ammoniacal brine, which is a mixture of 3 main components, sodium chloride, ammonia and water. Then carbon dioxide is passed through ammoniacal brine in carbonating tower. The result is the formation of 2 salts, sodium bicarbonate and ammonium chloride in dissolved state in water. Dear students, we only want sodium bicarbonate. Now what we do, we lower the temperature of this mixture. Due to poor solubility at lower temperature, sodium bicarbonate separates out. Sodium bicarbonate is further separated from ammonium chloride, which is in dissolved state in water, by the process of filtration. Sodium bicarbonate is further heated to produce sodium carbonate, the material that we want to prepare. Another benefit of this step is the production of carbon dioxide, which is fed to carbonating tower or reutilized. Further supply of carbon dioxide is done by the lime kiln, which is attached with the process, where calcium carbonate is heated to produce calcium oxide and carbon dioxide. Carbon dioxide is used in carbonating tower, where calcium oxide is mixed with water to produce calcium hydroxide. Calcium hydroxide is further reacted with ammonium chloride in ammonia recovery tower, and as a result we get ammonia, which is one of the raw material used in our first step. The only byproduct produced during this process is calcium chloride. Dear students, let's learn why the Solvay process is so successful worldwide. What are the advantages and industrial impact of this process? First of all, economic efficiency. Cheap raw materials and minimal fuel consumption make it cost effective. Second key benefit is the resource recovery, that is carbon dioxide and ammonia recovered and reused, maximizing efficiency of the process. The process has also environmental benefits. Pollution-free process with only calcium chloride solution as waste. Further, the product that we produce is of high purity, that is sodium carbonate, which is further used for industrial applications. Pakistan's ICI Kyoda 1944 and Sin Alkalis 1966 demonstrate successful industrial implementation of this process. So dear students, I hope you fully understand about Solvay's process. Jazakallah for listening.